All right, let's look at the rest of this. 31 through 40 on the final exam. And we have on 31 a non-constant growth, and we don't know K. We need to figure K out, so we'll start with that. KE, the cost of equity, is going to come from the risk-free rate plus beta times the market risk premium. Now, it's important that you read this correctly. The risk-free rate is 2%. Beta is 1.1. This right here is the return on the market. The entire thing is the market risk premium. So it tells you the market risk premium is 5%. So that was going to be 0.075, or K is equal to 7.5%. All right, so if I said the return on the market was 5, you would subtract the risk-free rate by 10. I said the market risk premium. Make sure you have those two terms, return on the market and market risk premium, straight. So when I read through this and I see it's not constant growth right away, I'm a little depressed because it's going to be more work, but I know how to do it. It says it's going to take 2 years for it to go to constant growth. So if it's 2 years to constant growth, it's D1 over 1 plus K plus D2 over 1 plus K squared plus P2 over 1 plus K squared, not cubed, but squared. Alright, so D1 is equal to D0, which D0 is $2.10 times 1.2, which is $2.52. D2 is equal to D1, 252 times 1.2, which is equal to $3.02.4. So I can do that. That's 252 over 1.075 plus 3.024 over 1.075 squared plus, I still need P2. P2 is equal to D3 over K minus G, because now it's gone to constant growth. D3 is equal to D2, 3.024 times the constant growth of 1 plus that, 1.03, which is equal to 3.11472. So P2 is equal to 3.11472 over K, which I found out to be 0.075, minus G, which is 0.03, which is equal to $69.21.6. So 69.216 over 1.075 squared. It's a lot of work, but nothing hard. Just go through the different parts there. 64.86 is going to be your answer. By the way, you look at the other choices, 69, 77, and 82. You know those can't be right. This is 69. It's got to be, well, you don't know that for sure, but you can feel when you add up 69, the 3, and the 2, you know it's got to be a number less than those added up. Alright, so let's go to 32 through 33. Well, 32 through 35, those are all one big question. So the first one is the initial cash flow. I have to read through here and see it's going to take me $32 million to expand the plant and buy the machinery. The firm has spent, I don't care about that. Now I'll look to see, is there any working capital that was involved? Yeah, they have to expand working capital by another $1 million. So that's the initial cash flow is minus $33 million. Alright, then question number 33, what's the cash flow in year 9? It could be really in year 1 through 14. They're all the same. Years 1 through 14 are all the same. And what I do here is revenue minus cost minus depreciation times 1 minus the tax rate plus depreciation. So revenue is $17,500,000 a year. Costs are $11,300,000 per year. Depreciation, I don't know. I need to figure that out. So depreciation is equal to the cost of my property, my plant and equipment, which is $32 million, minus my salvage value, which is $2 million. divided by the 15 years, so that's $2 million in depreciation. So minus 2. 1 minus a tax rate of 40% plus depreciation of $2 million. That equals $4,520,000. Alright, so put 34, I can put 34 up here. 34 is just the total cash flow in year 15. What's different about that is the terminal year, so it has the cash flow of year 1 through 14 just like all the others. So you do this for year 15, that for year 15, plus you get to sell the equipment for the salvage value of $2 million, plus you get your net working capital back. So that's that's $7,520,000. Alright, so now to get the net present value, you know this is cash flow 0, so it's CF0 in your calculator. This is cash flow 1, CF1, but the frequency is 14, that happens 14 times. This is cash flow 2, and it happens once. And then your discount rate is 10%. Plug all that into your calculator and you should get $2,097,655.62 for your net present value. Alright, so let's look at 36. 36, 37, 38 are all essentially the same problem. And what you're trying to do here, we're trying to find a net present value, which is my $6,000 plus $700 divided by 1 plus the cost of capital 8% to the first. Excuse me, plus 1,400 divided by 1.08 squared plus 1,400 divided by 1.08 cubed plus 1,600 divided by 1.08 to the fourth plus 1,800, not equal, plus 1,800 divided by 1.08 to the fifth. Now, the easier way to do this is using your cash flow keys. This is cash flow 0, cash flow 1, 2, 3, 4, and 5. You just do it that way. Interest rate is 8%, and that comes out with a minus 639.11. And remember the IRR, so question number 37, the internal rate of return is that I need to move this interest rate to make the net present value equal 0. So if I change that to make that equal to 0. So changing each one of those. Now I can't do that myself just by guessing. I have the calculator guess for me, and it's going to come out to be 4.31%. If it comes out to be error 5, that probably means you put this in as a positive and not as a negative. Then 38 was a profitability index. The profitability index is the present value of the benefits divided by the present value of the cost. Another way to think about that is it's the net present value plus the cost divided by the cost. The net present value is minus 639.11 plus the cost. Keep that as a positive 6,000 over 6,000. It's going to be less than 1.8935. No, this is less than 1, reject. This is less than the cost of capital, reject. This is negative, reject. Alright, now 39. 39 is one that you can do. It's more involved, takes more time. Another way, the average cost of capital is equal to the weight of the equity times the equity plus the weight of the debt times the cost of the debt times 1 minus the tax rate. I know the weight of the equity because it says in the problem is 60%. I know the weight of the debt is 40%, so let's find the cost of equity. Alright, so I'll do it right here. P0 is equal to D1 over K minus G. that K is the cost of equity. If I rewrite that, KE is equal to D1 over P0 plus G. I'm not given, and let's just do an algebra. I'm not given D1, I'm given D0, so D0 times 1 plus G over P0 plus G is equal to $2.90 times 1 plus the growth rate of 3% divided by the price of 33.75 plus the 3%. That's equal to 11.85%. So this is going to be times 0.1185. Now let's find the cost of debt. I need to know N, payment, future value, present value. Plug that in for the interest rate, and that will give me the semi-annual cost of debt, because this is a semi-annual pay bond. And it matures in 30 years, so 30 times 2 is 60 and a half years. The payment, it is an 8% coupon bond, so that's $40, $1,000 par. The price is $9.15. I need to make that negative, minus $9.15. Solve for that. And I didn't write that number down. Hang on just a second. Okay, that number is 0.04405. So I multiply by 2. My cost of debt is equal to 0.0881. So plug in right here, times 0.0881 times 1 minus my tax rate of 40%. This will give me my cost of, weighted average cost of capital of, oops, let me write this right, 0.9225, which is 9.225%. Alright, so all we have left is problem number 40, which I haven't worked out yet. Let me work that out, and I'll get right back. Okay, now the last one of the test, problem number 40. We have two machines. Let's do this as I'll do machine A first. And what I see here, I need to find the net present value. It's going to cost $10 million to install, so I need to find the net present value of A, which is minus the $10 million to install. And it's going to be $1 million a year in maintenance costs for 15 years. So what I can do is say N is equal to 15. Payment is equal to 1 million. Interest rate is equal to 5%. Future value is equal to 0. The present value of this is equal to minus 10,379,658.04. So that's minus 10,379,658.04. So their overall net present value is negative 20,379,658.04. Now, how would you ever do this? You have to have faucets and toilets. You're not going to make you money. You want to have the one that costs you the least amount of money to run. So that's why we're doing the present value, right? So this, the way to think about this is I could pay this amount right now today, and these toilets would work for 15 years. All right, let's look at B. I need to have the net present value of B. It costs how much to put in today? It costs $4 million to put in today. And then has some future costs to operate. This can run for 20 years. And the interest rate is still 5%. And the operating cost of the payment is $2 million. Future value is 0. Plug all this in. And the present value is minus 24,924,420.69. So minus 24,924,420.69. This is equal to minus 28,924,420.69. The important thing here is, alright, so it would cost me $20 million today to get machine A, get those toilets going for 15 years. It would cost me $28 million today to get these toilets running for 20 years. I can't make that comparison. I gotta compare equal time periods. So what do? I can come over here. I can say these things run for 15 years. Their present value, the cost of them today, is minus 20,379,658.04. Their interest rate is 5%. Future value is equal to 0. When I plug all this in and I solve for payment, the payment is equal to minus 1,963,422.86. So in other words, I could run this every year forever for $1.9 million. What about these? These will run for 20 years. The cost of them today is minus 28,924,420.69. Their interest rate is 5%. That future value is 0. I plug all this in and solve for payment. My payment here is equal to 2 million. This is negative 2,320,970.35. So I prefer this one. So the answer is A. Why do I prefer this one? It's cheaper, right? So just get this logic. You've seen this problems just like this before, but make sure you get this logic. I want to see, I can either pay $10 million right now and $1 million a year for 15 years, or I can pay $20 million today, or I can make payments every year of $1.9 million. Those all three are the same. I can do that for 15 years, and I can repeat the project, do it again forever. With this one, I can either pay $4 million today and $2 million a year for 20 years, or $28 million up front, or $2 million a year forever, because when this ends in 20 years, I can repeat the process. I prefer to pay $1.9 million to $2.3 million, so I choose machine A, and that's it.